a lesson on metric measures, or particularly converting metric lengths. Okay, but we're going to start off with a starter. I want you to pause the video, do these multiplying and dividing questions, and unpause when you're done, please. So write them on a piece of paper, unpause when you're done. Okay, so you're done. I've unpaused. Let's go. Right, so if I'm timesing by 100, I'm going to make my number bigger, and it's going to be bigger by 2 places. And a quick way of remembering that is just look at the number of zeros. So it's going to be 230, and that is a zero. Promise. 2.8 times by 10, it gets 1 place bigger. So 28. Now, if we're dividing, we do the same thing. We're shifting our numbers either bigger or smaller, but dividing, we're going to shift them smaller by 3 places. 3 zeros, so 3 places. So it becomes 0.54. You could put the 0 on the end, but we just don't need it. It's what we call a trailing 0. We just don't need it there. 2 places smaller for this one, so 0.28. 1 place smaller for this one, 0.45. Now, I know it's been the case that all of these have ended up as 0 point something. It's not that you just put 0 point and then write the number. It just happens in these cases that our numbers are shifting, say, 1 place, so the decimal point ends up there. Shifting 2 places, so my decimal point would have ended up before the 2. 3 places and so on. Okay, just a coincidence in this case. Right, 2 places smaller, and this is a good example. My number gets 2 places smaller, so 1.02. Remember, it's always the same digits, same order. You can't insert any digits or take any away. You're just moving it bigger or smaller. Right, 3 places bigger, which makes it 1020, so 1020. 2 places smaller, so 5. No, not 5.4. That's wrong. That is wrong, Mr. Nias. Get it right. It is not 5.4. Of course it isn't. So let's go back to my pen. No, 2 places smaller means it ends up as 54. Right, again, 2 places smaller, so 5.4 this time. 1 place smaller, 102. 3 places bigger, 2800. 1 place bigger, 1.2. 3 places bigger, 120. 1 place bigger, 540, and lastly 2 places smaller, which is 10.2. You could put the 0 on the end, but again, we just don't need it there. Okay, right, let's go into some metric measures then. A couple of thoughts first of all. Why metric? Why on earth do we use these measurements? And I'm going to answer that by asking a few other questions first, which is, have we always used metric? And the answer is no. We used to use something called imperial measures before we used metric measures. When did we change from imperial measures to this one? I think it was 1963. I'm just trying to desperately get it out of the back of my head. But it's around about 1963, so early 60s. And we went over to metric measures. But do we still use any imperial measures? Yes, we most definitely do. 2 real obvious cases would be pubs still serve things in pints, and we quite often think about milk coming in pints. The bottles, if you still get bottles of milk from a milkman or milkwoman, they come in pints, and if you look on the side of a milk bottle from a supermarket, it might say 4 pints on it, 2.2 whatever litres that is. Okay, so we do definitely still use them. The other one is miles. We still work in miles per hour. All our road signs generally work in miles, how many speed limits, and how far it is to the next town, and so on. And it's just a knock-on from when we used to use imperial measures. Why did we change from imperial to metric? Now, this is a really good question, and there would certainly be a certain generation of people that would disagree with using metric, and they'd say imperial is much better, which I'm going to show you why I don't think that's the case. And here's a quick video from NumberHub. Same guy, he's a brilliant guy. He also does some stuff on Numberphile as well. Look them up. It's really, really good. And this explains a bit why maybe imperial units of length particularly are not that great.
It has very recently been brought to my attention that during my number hub video on the A4 paper scale, I made an apparently unwarranted number of attacks on the imperial system of measurement, and I would like entirely voluntarily to apologise. Why wouldn't you take a barleycorn as the basis of your system of measurement should you be, I don't know, hypothetically, an industrialised modern superpower? And to apologise, I'm now going to give you the number hub guide to the imperial measurement system, because it all hangs together so nicely. You take 3 barleycorns, that gives you an inch. You then take 12 inches, that gives you a foot. You take 3 feet, it gives you a yard. You take 1,760 yards, you get a mile. A mile, alternatively, you can split into eighths. Each eighth of a mile is a furlong. Of those furlongs, you can divide them into tenths and you get a Gunter's chain. Each Gunter's chain you can divide into elevenths, and that gives you a fathom. If you take 15 fathoms, you get a shackles. Or alternatively, if you take 100 fathoms, you get a cable. You take 10 cables, you get a nautical mile. A nautical mile, of course, being wildly different from a standard mile. If you take 3 nautical miles, you get a league. Or alternatively, if you take a nautical mile and split it into feet, you get 6,080 feet. We're back at feet. If you take a foot and you divide it in thirds, you get what's called a hand. Of course, a hand is exactly the third the size of a foot. Each hand, if you cut it in half, you get a stick. Each stick, if you cut it in half, you get an inch. Each inch, if you take 3 of them together, you get a palm. A palm split into quarters gives you a digit. 3 digits give you a nail. 4 nails give you a span. 2 spans give you a cubit. A cubit divided into thirds gives you a shatments. Why wouldn't you call something a shatments? If you take 5 shatments, you get a pace. If you take 2 paces, you get a step. Of course, 2 paces to the step. If you take 4 steps, you get a rope. If you take 5 ropes, you get a Ramson's chain. If you take 50 Ramson's chain, you get a Roman mile. The Roman mile, of course, wildly different from the standard mile, because while the Roman mile is exactly 60,000 inches, the standard mile is 63,360 inches. Speaking of inches, if you take an inch and divide it into sixths, you get pickers. If you take a picker and divide it into twelfths, you get a point. If you take a point and divide it into 20ths, you get twerps. Or alternatively, if you take 6 points, you get a line. A line is exactly the same length as a poppy seed. And if you take 4 poppy seeds, you're right back where we started. 4 poppy seeds equals 1 barleycorn. What a fantastically logical and consistent system of units.
I love that video. I think it kind of hammers home the point of why imperial measures are very confusing. So let's have a little look at the question of, but why metric then? Well, frankly, let's look at these. 10 millimeters, so that's a unit of length. There's some millimeters down there. That'd be between that point and that point. That's 10 millimeters. It's the same as 1 centimeter, as it sort of says there. 1 centimeter, 10 millimeters. 100 centimeters would make 1 meter. 1,000 meters then would make 1 kilometer or kilometer. 1,000 milliliters equals 1 liter. 1,000 grams is 1 kilogram. 1,000 kilograms, 1 ton, 1 metric ton. Look, what have these all got in common? We're not sort of going, 12 inches to a foot, 3 feet to a yard. It's not sort of random numbers. These are all powers of 10, aren't they? 10 of those make that, 100 of those make that, 1,000 of those make that, and so on. All right, it's just a lot more kind of what we call base 10. It works around those powers of 10, which does make things much easier. It's just simpler. So let's look at a few, how to convert between metric lengths. So some equivalent metric lengths. Well, we've already said 10 millimeters is 1 centimeter, 100 centimeters 1 meter, and 1,000 meters equals 1 kilometer. I'm going to leave those up there because they're useful for what we're going to talk about here. And if you're making notes, I would definitely write down what I'm going to put down here and color code it as well. So let's think about a kilometer. Let's say I've got 1 kilometer and I want to turn it into meters. So look, I'm going to have 1 kilometer there. And I want to write that down in meters. Well, look, 1 kilometer equals 1,000 meters. So if I'm going from kilometers to meters, I need to times it by 1,000, because for every kilometer, I get 1,000 meters. So I just times it by 1,000, right? Okay. What about if I wanted then to go to centimeters? Well, look, there's 100 centimeters for 1 meter. So if I was going from meters to centimeters, I'm going to times it by 100. I need 100 centimeters for every 1 meter. And similarly, if I want to go from centimeters to millimeters, I'm going to times it by 10, because there are 10 millimeters in 1 centimetre. Now, if you remember to write this little chart down, kilometres, metres, centimetres, millimetres, look, it actually goes times 1,000, times 100, times by 10. Right, it's quite neat. And of course, if we're going back the other way, we're going to do the opposite. So millimetres to centimetres is going to be divide by 10. Centimetres to metres, divide by 100. And metres to kilometres, divide by 1,000. Yeah, just in that kind of little circles, I suppose, in a way. You just need to remember how many metres are in a kilometre, how many centimetres are in a metre, and how many millimetres in a centimetre. So we might have a couple of examples. Let's have a look at those. So what about if I wanted to convert 13 metres into centimetres? So there's my 13 metres. Well, it says on here to go from metres to centimetres, I need to times it by 100. So that's 2 places bigger, just like the starter. So that's 1 place bigger, 2 places bigger. So 13 metres is 1,300 centimetres. Yeah. What about if I was going to convert something from metres to kilometres? Well, let's write that down. 1,550 metres. And I want it in kilometres. So we're going metres to kilometres. Well, that's this way on the arrow. I'm going to divide it because I need a lot of metres to make up just 1 kilometre. So I will divide by 1,000, 3 places smaller, which is 1.55. Same digits, just 3 places smaller. And that's my kilometres, right? So it's quite straightforward. Much, much easier than converting imperial measures. Please don't write in with any complaints. Okay, there's 5 questions for you to do then. I want you to pause the video, do those conversions, write them down. You know, don't just do them in your head, write them down. And then unpause when you're done. We've unpaused. So centimetres to metres. Well, that's dividing by 100 because I need 100 centimetres to make a metre. And that will be 3 metres. Kilometres to metres. Well, that's timesing by 1,000 because I get 1,000 metres for every kilometre. So that will be 3,000 metres. Millimetres to centimetres. Well, I need 10 to make up just 1 centimetre. So I need to divide by 10 because there are 10 millimetres for every centimetre. So that would be 30 centimetres, the length of a long ruler. Metres to kilometres then. What do I do? Metres to kilometres, divide by 1,000 because I need 1,000 metres to make a kilometre. So this is actually 0.3 kilometres. Keep in mind, all these things are equivalent. I'm not changing the length, just writing it in a different unit. And lastly then, where's my pen gone? Come back, pen. Pen, where are you gone? There we go. Right, millimetres to kilometres. Ooh, okay, well actually, I'm going to cover this in just a minute on the next example. But what I do, and I'm going to show you that in a minute, is actually do a couple of jumps. I could do 3 jumps here. First of all, I'm going to divide it by 10. And that would be, so what we've got, 30,000. So this will be 3,000 centimetres. I'm then going to, what we're going to do here, we're going to divide it by 100. That will take it from centimetres to metres. So 2 places smaller. So that is 30 metres. And then metres to kilometres, we're going to divide it by 1,000. So 3 places smaller, which will be 0.03 kilometres. Okay? Right, and let's do a couple more of those actually. Let's show you more what I mean by that. How about if I'm doing 1.7 kilometres into centimetres? Well, I think the easiest way, you can do it in one jump, and to do that I'd actually be timesing by 1,000,000. But let's do it in a couple of jumps. Let's go from kilometres first of all to metres. And I'm going to times by 1,000 first of all. So that's 1,700 metres. And then we can go to the centimetres after that by timesing by 100. We're just using the same conversions as before. 2 more zeros there. Except I'm doing it in a couple of jumps instead of one. So that's 170,000 centimetres. Again, okay, so let's go from millimetres to metres. Let's write this down. 25,450 millimeters. Well, first of all, let's go to centimeters. So I need to divide it by 10. So one place smaller. So 2,545 centimeters. And then from centimeters to meters, I need to divide it by 100. So two places smaller. So 25.45. Well, that's meters, isn't it? God, let's redo that. That's rubbish. Rubbish, Mr. Nias. So when you're doing these, you're keeping, remember, the same digits. You're just shifting them in their place value, just shifting them across from where they were to where they're going to go now. Now, if you really struggle with doing those, you could say on this one, where I'm making them smaller, start off with your number, write it in a column, and then just keep shifting the numbers across. And if you get to a point where you've sort of gone past here, you just put your decimal point in. You know, and I could keep shifting those numbers across as many times as I like. And that's 3 places, yes, 1 and then 2 more places smaller. And just keep everything lined up. You know, you might want to put decimal points in those top ones, even though they're not usually visible. Okay, so there's a little strategy you can use if you're struggling. Meters into millimeters then. So this is going 2 jumps we're going to use here. Firstly, we're going to turn it into centimeters, so that's times it by 100, so that's 2 places bigger. 24600. And then I'll go to millimeters, which is 1 place bigger, times it by 10. So 24600. 246,000 millimeters. All right? Get the idea? Cool. Well, there are 10 questions for you to do. It's your last task of the lesson. I want you to write them down. I'll then reveal the answers in a little bit. Oh, actually, it's not the last task. I've got 2 questions after this, but let's pretend it is for now. All right, pause the video, unpause when you're done, and I'll just have a little sip of coffee whilst you're working. Okay, we've unpaused. Right, let's just show you the first one. Meters into kilometers. Obviously, going from meters to kilometers, I need to divide by 1,000. And so here come all the answers. The first one's 2.77 kilometers, then 900 meters, 2,700 meters, 9.4 meters, 530 centimeters, 640 centimeters, 57 centimeters, 11 meters, 1,200 millimeters, and 9,800 millimeters on the end there. Okay, I hope you got all of those right. Do let me know how many you got out of 10. But let's just do 2 more questions quickly before we finish, which are here. I want you to try a couple of these little problem questions. They're worded ones, but it's still just converting. So then, apparently I've got a news notification. I'm going to go read that whilst you press pause and do the questions. Unpause when you're done. Okay, we have unpaused. Let's go. Dexter rode his bike for 2 kilometers. Good old Dexter. He then walked for 955 meters. How far did he travel in total? Give your answer in meters. So we need to convert our 2 kilometers into meters, which is going to be 2,000 meters because I need to times it by 1,000. And then we'll add that together with the 955. So he walked a total of 2,955 meters. Mary has to travel 3.8 kilometers to work. She walks for 1,200 meters and gets the bus for the remainder of the journey. How long is the bus part of the journey? Give your answer in kilometers or kilometers. So I think we need to change the 1,200 meters into kilometers. Now to do that, we divide by 1,000. So it's 1.2 kilometers. And we need to find the difference. That's a subtraction sum, so 3.8. And we're going to take away 1.2. Why am I crossing that out? Don't need to. 8 take away 2 is 6. 3 take away 1 is 2. So how long is the bus part of the journey? It must be 2.6 kilometers. Okay, well done if you got those right, and I'll see you again next time.